All right, so here we are with solid geometry. Our objectives today in Chapter 11, Section 1 are to classify three-dimensional figures according to their properties, and then use nets and cross-sections to analyze three-dimensional figures. So we've got some 3D shapes. This one here is a prism that we'll go over in a minute, but the idea is that it's made up of 6 faces, so those flat surfaces. It's got vertices, okay, and so that's where each of those edges meet, and then of course the edges are all the lines that make up the faces. So if we go ahead over here to this three-dimensional figures directions or summary, three-dimensional figures or solids can be made up of flat or curved surfaces. So we can have, later on you'll see this one here, your cylinder with curved surfaces. Each flat surface is called a face. The segment that is the intersection of two faces is called an edge. And the point that is the intersection of 3 or more of the faces is your vertex. So faces, edges, and vertices are what we have. When we go ahead and name three-dimensional figures, basically they're made up of figures that have triangular sides or have square sides or rectangles. So if we take a look at what's happening here, these two are using this word prism or cylinder if there's a rounded side, and those have rectangle sides. Now, depending on what their bases are, all the rest of those sides are rectangles. These ones here have triangle sides. And so those ones are typically a pyramid shape, or in this case, a cone, which has a round base. So of course, anything that has a circular base is going to have a different name, but otherwise, when it comes to prisms, you name them as their base, so triangular, and then the word prism. So triangular prism is this one. Technically, this would be a circular prism, but we call it a cylinder. This one here is another triangular, but now it's a pyramid because it comes to a point here. And then the cone is technically a circular pyramid, but again, we'd call it a cone instead. So taking a look at each of these definitions, a prism is formed by two parallel congruent polygon faces. So notice that this top and this bottom do in fact have to be parallel. We'll also sometimes put in our right angles here just to say that this is going to meet this at 90 degrees. And those two faces are called the bases. And then everything else in the middle, all the faces in the middle, are those rectangles or parallelograms, because it could actually be an oblique, meaning kind of leans to the side. We'll go over that later, but it could also be a parallelogram. So then your cylinder is formed by two parallel congruent circular bases, so that's here. And again, sometimes to mention that they're going to be parallel, we do put that right angle piece here when we mention the radius or maybe the diameter, just so that you know that that does meet at 90 degrees. And it's going to have those curved surfaces that connect the base. So this is actually a rectangle if you would unfold it, okay? But you've got your circular bases on top and bottom. The next one is a pyramid, and a pyramid is formed by a polygon base, so that's this guy down here, and a triangular face, well in this case 3 triangular faces that meet at a common vertex, so that's up here. And then the cone is formed by a circular base, so that's down here, and a curved surface that connects the base to a vertex. So this one here is actually formed from a circle on its base, but then kind of a sector shape for its other piece. So this isn't necessarily a triangular side, but it does have a sector, so that's going to be there. All right. After that, we've got some cubes. So a cube is a prism. So as we looked at here, our prism would just be a cube if it had a square on its top and its base, and then squares on all sides. So a cube is a prism with 6 square faces. Other prisms and pyramids are down below here. And so you can see that they're named by their base and then the word prism. So in this case, triangular, because the two that are not rectangles, triangular prism, rectangular prism, pentagonal because it's got a pentagon on the top and bottom, and a hexagonal or a hexagon prism. Then these down here, again, triangular because its base is triangle and then all of its sides are triangle, so that's why it's a pyramid. This one's your rectangular pyramid, a pentagonal pyramid, so if you can see there are 5 sides in there, and then your hexagonal or hexagon pyramid. All right, so we're going to go ahead and classify each figure, just meaning name it, and then we're going to name all the vertices, edges, and bases. So when we take a look at this, and these are actually scanned images from the textbook. So taking a look at this one here, it's supposed to be, I don't know what it's technically supposed to be, but I do see that its base is a rectangle and all of the sides are triangles. So if you have a base of a rectangle and sides of a triangle, we're going to have a rectangular pyramid. So its classification is that it's a rectangular pyramid. And then after that, we're going to list all of the vertices, edges, and bases. So your vertices are going to be the capital letters of A, B, C, D, and E. Your edges are going to be the 4 that make up the square on the bottom, and then the 4 that make up the sides of the triangle, reaching up to your vertex E. So if we list each of those, we're going to have BA, AD, DC, and CD. AD going along the back, DC coming along the side, and BC along the front. And then up the sides, we have BE, CE, DE, and AE. All right, and then we have our faces, or the bases. Oops, that's an S. And so your bases, in this case, are going to be a square. So we can call it square ABCD, or sorry, rectangle. But then we technically have all of these faces as well. And so we have 4 triangles that come along with that. And so we have triangle EBC, triangle ECD, triangle EDA, and triangle EBA. So those are technically faces versus the bases, which in this case there's only one. All right. So then moving on to this one here, it's a can, and cans are cylinders. So we're going to name it as a cylinder. Again, technically you could call it a circular prism, but we're not going to do that. Then we have our vertices. And this is tricky because you're looking for where do each of these edges meet, and it turns out there are none. Then we look for edges. And again, those are those straight edges that would connect to make vertices, and so there are actually none of those as well. Potentially, you could try to make this an edge, but if you look, there's no vertices to connect them, so it's kind of hard to name it. And then our bases are circle P and circle Q. All right. Moving on to our next idea, we have nets. All right, and so nets are basically this idea that if you cut this out of paper and folded it in the correct manner, you would end up with a 3D shape. So it is a diagram of the surfaces of a 3-dimensional figure that can be folded to form that 3-dimensional figure. So this one here is going to become a triangular pyramid because you've got your triangle on the middle here, that would be the base. And then over here, you'd fold those up, those peaks, to a vertice. And so you'd end up with something like this, with a triangle on the base. This one over here is actually a cylinder, so that's that kind of can label, and then those are the two tops of the can. All right, so those are nets, and so we're going to some examples of nets. This one here, notice that it has triangles and rectangles, so you might think it's a pyramid or a prism. But in this case, these two are the bases, because of course you need two bases. So if this is the base and this is the base, that means that we are going to call this a triangular. And then because these are the faces, we're going to call that a prism. So that will eventually fold up into a triangular prism. This one over here, because it has triangular sides and there aren't two of those, there's only one base. And it very much looks like a square, so we'll just call it a square, but you could say rectangle. So here's our base, and then all of these on the outside are our edges. And since all of the edges are the faces, they're faces. Since all of the faces are triangles, that's where the word pyramid comes in. All right, our last piece is a cross section. So basically, if you imagine kind of like that kinetic sand video where you cut kinetic sand and then it kind of makes these nice slices. The idea here is that a cross section is that knife that cuts through that sand, and then you would get a new face. So for instance, if you tilted that knife a little bit, you would end up with a different face than if you tilted it another way, or if you were just straight up and down parallel to the bases. So a cross section is the intersection of a three-dimensional figure and a plane. So you've got this plane that's going through here, and kind of what would that shape look like on top of the piece of paper. So on top of this piece of paper, you would have just another hexagon because it's parallel to the bases here. Over here, directly up and down, you'd get a triangle if you cross section here. Still looking at these examples down here, if I make a cross section that very much looks like it is parallel to this base here, you're going to end up with a triangle that would have been cut from that. So we've got a triangle, that's the cross section. And then over here, again, if you take this knife and cut it through here, especially parallel to the rest of the pieces, based on the fact that this is a three-dimensional shape drawn on 2 dimensions, you might say that's an oval. But again, the perception is that that is a cylinder, so circle. All right, so those are the notes for Chapter 11, Section 1 for geometry, solid geometry. And so you have an assignment now.